Hello and welcome to my talk on environments as a service. I'm really happy to have you here, and through this talk, I hope I can introduce you both theoretically and practically into environments as a service and ephemeral environments in 30 to 40 minutes. Environments as a service can definitely help increase both productivity and improve the developer experience, solving current issues in terms of environment management. Environments as a service is about empowering developers to create production-like environments to be used for both development and staging purposes. And the purpose is actually to allow developers to concentrate on direct productive activities such as coding or application architecture, or to invest more time in automated tests. So let's dive in, shall we? In this talk, we'll discuss about current challenges faced by engineering teams in terms of environments that they're using. Then we'll take a look at possible solutions and see the benefits they bring into the environment's equation. And we'll also see how all of this actually works inside Bunny Shell. And then we'll wrap it up. So, in terms of challenges faced by engineering teams, they are different for each role. Software engineers face their constraints, which limit their possibilities or consume time in a recurrent manner, like working with simulated dependencies. This means uncovering integration issues pretty late in the process, which in turn generates significant rework as a ticket needs to be raised, then document the whole context, and only after that the entire process basically rewinds. The ticket reaches the developer, a fix is produced, a test is remade, but in the meantime, some time has passed, the developer has lost focus on this task, and so on and so forth. I'm sure you're familiar with what I'm talking about. Another issue is that limited laptop resources imply juggling with, ad hoc partial environments. So they basically fit into the local machine and they deliver a subpar performance. Sometimes it's outright frustrating, to say the least. And this is a real turnoff, unfortunately, while being in the zone, in the focus area of the day. Maintaining your environment working, often it's left unnoticed, but it's a lot of effort put into there, and therefore time is actually spent away from a developer's main activities, direct productive activities, as I've referred them earlier. QA engineers, they face other challenges, which in turn create bottlenecks and also consume time. It all boils down to time, basically, right? It's the most precious resource that we have. So, for QA, having a small number of environments, often that small number is actually one, or in many teams it's less than one because they share an environment. Multiple QA engineers share an environment, and this greatly limits their exploratory testing in terms of time and both creativity, as it's unnecessary stress. And it obviously rushes the process of validating or actually testing changes. And I personally know more than a few QA engineers who basically shifted their working schedule only so they can have an environment to work on uninterrupted during off time for developers or for other QA engineers. And that's really a shame because we really have the tools to fix this today. Another issue is that testing a feature together with other related but actually separate features creates additional complexity. And while trying to isolate a scenario or maybe reverse engineer something weird that happened, you definitely don't need this additional complexity into your process. And unfortunately, this is the status quo. It's something that it has become the status quo over the years, actually. For far too long, the status quo was perceived as the cost of doing business, but it really doesn't need to be like this. We now have all the tools available to make things better. We have containerization, we have container orchestration that really works at scale. And fortunately, we see that environments as a service, is starting to become a thing. Moving towards the solution. Self-service is actually the only way to move forward, really. Decoupling the dependency on DevOps engineers for pre-production systems and allowing DevOps to focus on production system is truly a must. And I personally don't know of any company who wouldn't love to achieve this status. So, on-demand environments and preview environments. They unlock the ability to test features in isolation and greatly enhance the collaboration between stakeholders, the product team and the engineering team, and with other teams from the companies as well, support for trainings, and there are many scenarios. Actually, I'm not going to get into this at this time. Another very important aspect is remote development. This allows developers to start coding on a project within minutes. Obviously, once an environment configuration has been defined, but after that, it can be replicated and it can be definitely started within minutes. The code will basically run in a Kubernetes container, and the environment will reflect changes in real time with debugging capabilities. The development experience does not change at all. You can use your favorite IDE and the same debugging tools that you're used to, so everything should be already familiar. And costs. Any viable solution must, however, take costs into consideration. And I'm really sure that I don't need to go deeper on this topic. Before seeing the benefits, I would also like to graphically present what shortening the feedback loop actually means. Instead of merging and then deploying the code into an integration branch, it means you have real-time feedback while developing. This is what it's all about when it comes to development environments. And real-time feedback also has a performance component attached to it. So the performance of the cloud machines is far superior to even the best of local computing power. And we've felt that firsthand here at Bunny Shell, and this is beyond any doubt. Zooming in a bit on the process of development, let's compare what traditional development with testing real services looks like for most of the companies today. By services, I mean cloud-native services or other kinds of external third-party dependencies. I'm sure that you get it. And this is what it can look like also today or tomorrow or pretty soon, either way. It really depends on you. You can have instant feedback instead of needing to continuously commit and push, then wait for a build and deploy. And if it doesn't work for the first time, as it usually does, it's a rinse and repeat procedure. I know you feel like life is going past you when you wait for a pipeline to finish with fingers being crossed. And that's what we are referring to as idle time here at Bunny Shell, time that's left totally unused. So, the benefits. Some of them we've already touched until now, but mainly there are productivity increase, which also brings in inherent quality increase, far less context switching, and this allows engineers to truly focus. And let me ask you a question. When was it the last time you were, as an engineer, in the zone for 2 or maybe 3 hours of uninterrupted session of work? And yeah, that's that's quite a challenge, unfortunately, today. Moving forward, processes are streamlined as bottlenecks are removed along the way. Releases can also flow better as one single issue will not block multiple changes going live. The quality of the reviews grows exponentially when the reviewer can also test the code. And I don't refer here just to UIs. Interacting with application allows for a faster, deeper understanding of how a system works and how the user can also interact with it. Also, shareholder feedback can come in much early, shortening the overall feedback loop. Self-service obviously allows DevOps engineer already swamped with work to do. It allows them to focus on what is most important, and by this I mean the production systems. Last but definitely not least, onboarding becomes a bliss for new people joining a team. It really makes a huge difference to learn an application while it's up and running, as opposed to figuring out things while it's still trying to fix your local setup at the same time, isn't it? So enough talk, let's see some action too. It's time for the demo. So to demonstrate the value of environment as a service, I will next deploy an application starting from a Docker Compose file, which many teams already have today. But you can definitely use Kubernetes manifests or Helm chart if you have them. And you can obviously use combinations of them. You're not restricted to a single type of component within an environment. Afterwards, I will start a development session to demonstrate how it actually works from a user's perspective. And ultimately, I will perform some debugging while in the remote development setup. Due to time constraints, we'll be working with a simple application, simple scenarios, but nevertheless, real-world scenarios. So having more components in an environment or having many more lines of code doesn't really change the principles demonstrated here. Enough talk, let's dive into the Bunny Shell platform. Sorry for that. So I switched over to Bunny Shell, and I'm going to create an environment. I'm going to name it Conf42 demo. I can create it from Docker Compose, Helm chart, Kubernetes manifests, as I already said. You can also use Terraform modules, but we'll definitely not go into this demo. And you can use existing Bunny Shell templates, but these are not the scope of this demo either. So I'm going to select GitHub account. This is an account that I have integrated earlier, and I'm going to use our demo books application on the master branch. This is a GitHub repository containing a Docker Compose file, and pretty simple setup composed out of a backend, Postgres database, and a React frontend application. The backend is written in Node, and after parsing it, Bunny Shell has generated for me an YAML, which is basically the definition of the environment in Bunny Shell. We'll look into it a bit later down the line. In order to save some time, I'm going to deploy the environment first. So this is the environment details screen which I'm on. I'm going to click deploy the environment. I'm going to select the Kubernetes cluster, which is the dev cluster. For me, it's a cluster that we have connected to our organization. But you can also use the Bunny Shell managed cluster to try things out or see how it goes. I'm going to create a custom URL, a personalized URL for this environment named Conf42, and I'm going to hit deploy. What happens now is that the environment has become queued, and as soon as the worker frees up, it will pick up the environment, perform the build and the deployment. And it has already started. The environment is already deploying because I already deployed it earlier and I had the builds cached. So this is something that definitely helps you save time in case things are not changed to an environment or multiple environments, multiple colleagues deployed the same, I don't know, master branch for the front end, for example. This is the pipeline that was generated for this environment, and depending on how the environment looks like, your pipeline might look differently. As I said, going back to the configuration, let's see what it's all about. So I have here a backend application component, which is for this repository, the master branch, and it's located in the backend folder. It's a monorepo. Under Docker Compose, you have, well, Docker Compose syntax. Probably you're already familiar with that. And we also have a host exposed here, which has a backend prefix, and then the environment-based domain is interpolated here. You'll see how the environment looks like in a bit. There's also a database, which is, I already said, a Postgres. It's using the standard Postgres image, exposes some ports internally, exposes no hosts, externally, and it also has a volume, a persistent volume attached, persistent volume, which is defined at the bottom, very similar to Docker Compose. There's also a front-end application, which receives the backend URL as a build argument. So this is it. Let's wait for the pipeline to finish, and it's still currently deploying. I'm gonna go a bit into the settings to also show you the availability rules. I mentioned the cost consciousness of the platform, of any environment as a service platform, and I can select here, I don't know, let's say want to have environments running from 9 a.m. to 6 p.m. from Monday to Friday. I can have this. I'm going to save it, actually. And the environment will follow these rules. Obviously, you can define environment variables. You can also define application variables, which are basically environment variables at an application layer, and we have some defined for the backend application. For example, it's the database credentials and also the front-end URL for the course. So I'm gonna go a bit into the pipeline, and we can see that the deployment is also almost finished. It's finished successfully. As a side note, we can see that we have here under the component, we have the Kubernetes resources, and I can click the deployment, and this will show me these are the actual live container logs. It's the container output for my backend services. I can also see the Kubernetes events attached to this deployment and the actual manifest which was deployed. So let's see how the application looks like. There's a small issue with the front-end application. Let's debug it. Let's see what's the cause. So I'm gonna go to the front-end deployment, and I can see that the application actually started now. So it was a bit lazy to start. That's fine. So I'm gonna add a book. Conf42 book. It's called the API stored in the database. refresh the page just to prove that we have persistence. And going back into Bunny shell, I said that remote development is the next thing. So let's copy this command, and I'm going to switch over to my web store since this is JavaScript application. But it obviously you can use your own ID, any ID you prefer to. So I already have the demo books repository cloned. It's in the playground demo books path, and I'm going to open a terminal. I can see that I have here the backend application. I'm going to go into the folder and run the command here. Obviously, the BNS command requires you to install our CLI and then authenticate with it. I have done this prior. Remote development can be done in one of two ways. With local files, which is the method I'm demonstrating now, or without local files, which doesn't fit into the scope of this demo. So what I need to provide now is the local path, which is the current folder, which I'm in, and also the remote path, which is the path which I know from the container. It's the work diff from the container is the path from the container in which the application is located. So what happens now is that Bunny shell changes my pod definition so that my local files are synced into the container. I'm not going to go into too much detail, but on the surface, I can tell you that we're using mutagen to synchronize the files from local into your container. The files are synchronized now, and the pod definition is changed, and it has succeeded. Now I'm actually in the container. So what I can see now is the application folder structure within the container. Now I need to start my application, and I'm going to start it by running npm run start dev. I can obviously see that from my package JSON file here. So the application has started, the server is running. Let's switch back to the browser and let's open the application, the backend application directly. So this is the welcome route. Let's say it displays a very simple welcome message, and I would like to modify something on this route. I know already how to perform a small change. I'm gonna go here and add that Conf42, and once I save the file, you can see here on the terminal that the application was restarted because the files were resynchronized. And sorry for that, I forgot to switch to the IDE. So what I did was to enter the server.js file and modify here the message for welcome. I'm gonna hit save again, and you can see that the application was actually reloaded due to the file sync. I'm gonna go back to the browser now, and if I hit refresh here, I can see that Conf42 appeared. So the sync is actually working. Any change which I do now in my ID with my local files will get almost instantly synced in the container, and I will be able to see the live changes. So the last bit of the demo is the remote debugging part, and for this I'm going to switch again to the IDE. There's one more thing I need to do in order for the debugger to be able to attach to the running process. I need to run the same command with port forward. Okay. and the debugger is running on the 9229 port. And this tells Bunny Shell essentially that I need to forward my local 9229 port into the container, same number of the port. So Bunny Shell is again asking me for my files, and it will ask me for the sync. It changes the pod definition, and it will quickly check if the files need to be synced, and this is it. I'm gonna run again npm run start dev, which, by the way, has this inspect flag, which ultimately allows me from my local machine to attach to the session. And I also have a breakpoint here added. What I'm gonna do is go into the browser and hit refresh. Okay, nothing happened because I forgot to attach the debugger. I need to run this. I have made a minor configuration here. I mapped the local backend folder to the path in the container from user source app backend. It's basically the path I've synchronized the files into. I'm going to show the documentation on how I did that. It's a 3-step process, very easy. And now I'm going to refresh again, and I refreshed the page in the browser, the backend page, causing a request to be made. And I can see that I have here the call stack. It's the standard debugging procedure. I have access to variables. I'm able to execute functions. I can step into functions and whatnot. And I can also let the request finish. So this is the remote development in Bunny Shell with debugging. I'm gonna go quickly to the documentation and also show you how the port forwarding was set up. We have a bunch of examples here for Node.js. I started the remote development with the port 9229 forwarded. You already saw that. And from the configurations from WebStorm, I added an attached to Node.js configuration, and then this is what I did. I mapped the backend folder into the containers folder. So this was it, and then I hit debug. So this was it. I hope you found the demo clarifying and things are much more clear for you now. And I hope that you find it easy to follow as well. I want to say that environment as a service concept can truly revolutionize how engineering teams work and how they interact with other teams as well towards delivering a better product and delivering it faster. And very important, being more happily while doing so as an engineer. Just to recap, self-service is crucial in moving forward for any kind of change we will bring in how engineering teams work. And with environment as a service, you can have real production-like environments for development, for staging, for UAT. I mean, getting feedback from stakeholders in a real-time fashion, and also for end-to-end testing. Remember, this is not a replacement for your current CI, but it definitely can integrate with it and help you implement end-to-end testing in a much more sane way with completely isolated environments, which only live as long as they're needed for the duration of that pipeline, for the part of duration of that pipeline, to be more precise. and the concept is also cost friendly. So this was it. I really hope you've enjoyed it as much as I did, and I'd be really happy to connect with you and have you share your thoughts with me on the environment as a service topic. But not only that, anything engineering related. Have a great day ahead. Thank you very much for attending and all the best. Bye.